I will be discussing the problem statement subtree of another tree. The problem statement says given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot and false otherwise. A subtree of a binary tree is a tree that consists of a node in tree and all of this nodes' descendants. The tree could also be considered as a subtree of itself. The problem asks to determine whether a given binary tree subroot appears anywhere inside a larger binary tree root as an exact structural and value match. In simpler terms, we are scanning the larger tree to see if there exists any node whose entire subtree is identical to subroot, meaning the node values match at every position and the left/right child structure is the same. The subtree must include all descendants of the chosen node, not just partial matches, and the comparison must be strict, no extra or missing nodes. Importantly, the entire root itself can count as a subtree if it matches subroot exactly. The solution code checks whether tree T exists as an exact subtree within tree S by combining tree traversal with tree comparison. The is subtree function recursively visits every node in S, and at each node it calls same tree function to check whether a subtree rooted at that node is structurally and value-wise identical to T. If it is none, the function immediately returns true. Since an empty tree is a subtree of any tree, if S becomes none while T is not, it returns false. The helper same tree function performs a strict recursive comparison. It returns true only if both nodes are none, or if both nodes exist, have the same value, and their left and right subtrees are also identical. If a match isn't found at the current node, is subtree continues searching in the left and right children of S, ensuring every possible subtree root is checked until a match is found or the tree is exhausted. The time complexity of this solution is big of n into m. The space complexity is also big of m into n into n plus m. The patterns which are observed while solving this problem statement are: first is tree traversal plus condition checking. Second is DFS on trees. Third is recursive decomposition. Next is helper function pattern, compare versus search separation. Next is structural equality checking. Next is top-down recursion. Next is early termination / short circuiting. Next is brute force on trees, where we try every node as root. The next is base case driven logic, and the last one is recursive backtracking on binary trees.